The broadcast is now starting. All attendees are in listen-only mode.
Hi everybody, I'm Lorna. I'll be presenting the webinar today. I'm conscious that not everybody has joined yet, so we'll give them a few minutes and we'll begin shortly. Okay, well, good afternoon, everybody. Thanks for joining. I've just given a few extra minutes, so hopefully most people who wanted to join the session today have had the chance to do so. Before I get started on talking about RabbitMQ and get too excited to remember to tell you this, I want you to have a look at the GoToWebinar controls. There's a questions box. I'll be trying to watch this while I'm talking, but if not, I'll just pick up all your questions at the end. So just feel free to type in there at any time if there's anything you'd like me to recap on, or if you have any other questions that I should answer. Okay, I think that's all the housekeeping. So hi, I'm Lorna. I really like queues, and I'm working mostly at the moment with RabbitMQ. By day, I'm a developer advocate with IBM. So I work mostly on anything that stores data, including queues, on the Bluemix platform, which is IBM's cloud platform. I will be at Codemotion Milan. Now, this will be my first trip to Milan, but not my first trip to Codemotion, because I've spoken at the events in Berlin and in Rome. And I'm quite looking forward to this one. So I have a slide in my talk to tell you about which slot I'm giving there. But because I'm involved with that event, it means they let me do their webinar too. So here I am. Let's start by talking about queues. So we use queues for a bunch of different things, and they can solve a number of different problems. One of the things I like most about queues is that they're useful even for an existing application. So you can add a queue into an existing application. It's not like, oh, you're using the wrong database, you must take it out and use my new technology instead. The queues are a complementary technology in addition to the stuff that you're already using. So you can add a queue to your application. And I think that's really valuable. And it means that this technology has a really wide appeal and will be useful to many of you. We use queues for many different things. So it's useful for anything where you want to do an asynchronous process. So if you want to send an email message, or if somebody's uploading a file and then you need to create thumbnails or watermarks or re-encode the video, we don't want to do that on the web server. We just allow the user to upload the file, save it in some object storage, whether you're using S3 or something else, and then process it later. Put a message onto a queue that lets another system pick up that message, find that new upload, and do that processing. But we're not doing it on the web server, and we're not keeping a user waiting while we do it. Queues are very useful for loose coupling points in an application. If you go to any talk about software architecture, you will always hear about, oh, you must loosely couple your components. Well, that's nice, but it's rare to see any real concrete advice on how to do that. Queues are actually a very good way to loosely couple things. So if you have two components, and those components might be written in completely different technologies, they might be maintained or created by different teams. It doesn't matter, because all of the different programming languages will be able to talk to a queue. And as long as you agree what format the data should be on and how that message should be put on the queue, it's a very good way for systems to speak to one another. And because of the asynchronous element, it's nice and loose. It enables us to be protected against sudden bursts of heavy load for work where it isn't critical that it's exactly real time. If it could wait a few seconds, the queues can help us hugely. And also it allows us to scale up different parts of the system. So if we have one thing which is causing a lot of load on the server, we can move that to a worker script, something which is only consumed by messages on a queue. And then we can put more of those workers, more of those consumers, and scale that out horizontally and get more bandwidth through it without needing to affect our existing web server. And these legacy applications, this adding queues to give more capacity and more life to an existing system is something that I've used to really good effect in the past, as well as obviously implementing it on purpose in a new project with a good understanding of what the requirements of that project will be. Today's talk is all about RabbitMQ. My examples are RabbitMQ specific, but I am not trying to advocate that you should only use RabbitMQ. I think queues in general are a really good addition to a software platform. So I've put a few of them here, and I hope that most of what I'm going to say today will apply to most of these tools. I've used them all, so I'll try and call out where the differences are. Our examples are RabbitMQ. We have it available on the Bluemix platform. I'm working with it a lot at the moment. It's written in Erlang. It's an open source project. It's an extension of the AMQP messaging protocol standard. So it is standards based. It has some extra stuff on top of AMQP, but it means that you have a choice of libraries. Some of them are RabbitMQ specific. Some of them are just AMQP libraries that will cover almost everything that you're likely to need. Some of the other tools listed here then, we've got Gearman. That's a really nice open source project as well. It's one that I've used in the past. Gearman is very much a job queue, which fits well with the examples that I'm giving today. But some of the others, including RabbitMQ, are more of a message queue. So you would be able to route messages to multiple queues, consume them at different times. They're a little bit more powerful. Gearman is very much based around queuing up jobs and like processing units of work. We've got BeanstalkD. It's a very nice, simple, lightweight, open source queuing protocol. I've used BeanstalkD in the past. It once protected me from, in England, we have this very popular sport called football, which I think you have in other places, including Italy. And a famous footballer tweeted a link to my new project, which was live, but we weren't really expecting any traffic yet. I had BeanstalkD in that system, and it really helped to just smooth out the bumps of that heavy initial load where everybody tried to register and we had to thumbnail all those avatars. The queues got quite long, but the system stayed up. And BeanstalkD definitely saved me that day. Also, I was on a plane, so the application had to look after itself, and the queue really helped it to be resilient in that situation. You see Kafka very commonly with product name Message Hub on Bluemix, but it's an open source project. Kafka's a really interesting one. It's slightly different from the others in this list in that it tends to be more about streaming batches of data. You tend to deal with multiple sort of chunks of data coming through rather than doing complicated processing on individual pieces. So Kafka's a little bit of a different use case, but there's lots of things I'm talking about today where it would also fit. I have Redis on this list. Now, Redis isn't well known as a queuing tool, but it does have some simple queue support. And also, I find for the majority of web applications, you already have Redis in your stack. So if you need to solve a problem like tomorrow, then a very simple Redis queue will enable you to take advantage of some of the stuff that I'm going to show you today, prove whether the queue is helpful, and if so, then you can scale up to one of these other tools later. But it will allow you to very quickly prototype, and it's worth a mention because most people have it in their stack, so you aren't left, with a big problem to add an operational overhead of new servers, new backups, and all that sort of integration. Most people have Redis. So in an emergency, feel free to use Redis. So let's talk a little bit about RabbitMQ. Now, I mentioned it's open source, so you may want to be running your own version, and certainly for development locally, I would recommend this management plugin. RabbitMQ has lots and lots of plugins. You go and have a look at the docs, it's very good. But the management plugin, there's the URL for it. You plug it in, and for me, it looks like this. So you can see the queues messages arriving in queues. You can see if it's being processed. On a more production system, you can see I've got like 2 messages in this example, but on a production system, you can see if the queues are growing very rapidly or not. You can run this as a dashboard in your office. It's really, really valuable. I'd like to just cover some of the words that we use when we talk about queues so that I'm not using too much jargon that you're not familiar with. We say broker, the message broker, and all that means is the RabbitMQ instance or server. Within that broker, we have the exchanges, and these are where we send the message to. When we send a message to a RabbitMQ server, we connect the broker and we say, send it to this exchange. So there can be multiple exchanges within the broker. All of the messaging, all of the queuing systems have different topics that you can subscribe to. MQTT has this, different channels. You can name your queue. RabbitMQ is very fully featured. So you can send messages to a specific exchange, and you can give, with that message, you can give some information about how it should be routed. Now, the queues in RabbitMQ are all attached to exchanges. We say they're bound to exchanges, and we bind them with a binding key. And the binding key is a rule, and it can contain wildcards. It's a rule for messages with this routing information should go into this queue. So the queue has a name, but it also has a binding key, which dictates which message routes should go into this queue and which should go into a different queue. Messages can also go into multiple queues. So it is possible in RabbitMQ to copy that message and put it in different queues. The message itself, well, that's the data that we want to process, and the message will come with a routing key. So some information about where this message should be routed. And so that works with the exchange and queue and binding key setup to get things routed to the right place. Don't worry, I have pictures in a minute. Hopefully all will become clear. This is just the words. And finally, you'll hear me talk about a consumer or a worker. These are the scripts that take messages from the queue and then do something with them. So typically they're doing the unit of work that we're interested in. Exchanges, we've just talked a little bit about this, looking at how they manage routing. There are queues attached to exchanges, or we might have many exchanges within a single RabbitMQ server, within a single message broker. The exchanges come in different types. So you can have what we call a direct exchange. This is very simple, and it's more like the setup that you find in Gearman or in BeanstalkD, where you just give a queue a name and messages with a route that matches the queue name go into that queue. So the message comes in and it goes into exactly one queue on an exact match on the routing key. So this is a very easy way to get started, and I would recommend for a simple application, direct exchange can be a really good way to get started because you can create the queues, but you don't need to set up lots of binding routes. A very common type of exchange that we use in RabbitMQ, which you'll see in a later example, is called a topic exchange. And this is where we have an exchange. There are queues bound to the exchange, and they're bound by binding key. The messages are then routed to as many queues as the message's routing key matches the queue's binding keys. So we can have messages going into multiple queues if we need multiple consumers to respond to a particular event or a particular piece of data. The final type of exchange that I want to mention today is a fan-out exchange. So you put the message, you send a message to an exchange, regardless of the routing key. If it's a fan-out exchange, then every message will go into every queue that's bound to an exchange. So if you're doing like PubSub, you need to notify a bunch of people, the fan-out can be a really good pattern. The majority of web applications, or most software applications, use topic, but direct can cover your use cases for a bunch of simple ones. In RabbitMQ, we also have what we call a default exchange. So if you don't specify the exchange, if you pass an empty string for the exchange name, then it's a special direct exchange. So you have a default exchange, you just create queues, and then you can simply immediately start sending things. And if you look at the very good documentation on the RabbitMQ homepage, the Hello World examples use this built-in exchange. So you don't need to worry about exchanges or binding keys just to start using queues in RabbitMQ. The default exchange kind of gives you that for free. It's really, really nice. The queues then can have, there are some special things that I want to tell you about queues. They have wildcards in their binding keys, and this is how we can set up queues to receive more than one type of messages or messages to be routed into multiple queues. Queues can also be durable, and by durable I mean they survive a restart. So if the Rabbit process restarts, or if the whole server restarts, if the message queue is configured to be durable and the message is also configured to be durable, then you won't lose data on a restart. And this can be really, really valuable. And it's something that it gives you over using a simpler system. A lot of them don't have quite the same persistence settings. So you can set up a queue to, like I say, survive their restart. Queues can have a maximum length. This is great because it stops the queue just growing and growing and growing and eating all the RAM on the server and then causing things to fall over. The maximum length is nice, but look out, because when the queue is at its maximum size and a new message arrives, that message will be accepted into the queue, and the oldest message that was just about to get processed will get dropped, which is often not what you expected. As long as you know that the oldest one will get dropped and the newest one will be accepted into the back of the queue, then you're okay. But do look out for that maximum length setting because it can be confusing. You can also configure a queue with a setting for what we call the dead letter exchange, which sounds kind of terminal. But all it is it's the name of another exchange somewhere. And there's nothing special about the dead letter exchange. We just nominate that other exchange to be our dead letter exchange. And any messages that would have been dropped, perhaps because the queue was too long or something went wrong in processing, those messages will get rerouted to the dead letter exchange. And then we can go and look in the dead letter exchange later and see. It's just like a really powerful log of what didn't get processed. And it'll help us see which messages are not being processed for whatever reason. I am often asked how to handle feedback with RabbitMQ. So you put a message in a queue, and ideally your application should then just carry on and do something else, and it should be processed asynchronously. Sometimes we need to give some feedback to the original application that put the message in the queue once we finish processing it. And in that case, we normally communicate back in the other direction, also using another queue. And I have an example of that later on. The first example I'd like to look at today is an application which sends webhooks. So it's a really, really simple application. I created it as an example. The code is on GitHub. Here's the link. If you want to have a look at all the code or get the code and run it, it's a winning combination of PHP and Node.js because I write more than one language now. This application is a simple guest book. So once upon a time, way back in the golden age of the internet, all right, it was the dark ages, I admit it, we used to have guest books on our website. So if you visited a website and you liked it, much like we do with like holiday cottages and hotels today, you could write a nice message in their guest book to say how much you'd enjoyed your visit to their website. Yes, it was really a thing. In my imaginary application, what I've done is I've created a modern addition to this so that we can get notifications of new guest book comments. Perhaps I could send those to my Slack bot or something. So all this is a simple guestbook application, saves it to the database, and then sends a webhook. So you have to set up the webhook endpoints in advance. And if you actually run the app, you can see there's just a list of webhooks. You put URLs in there. There could be a bunch of webhooks listed so that when we add a comment, we need to send notifications to lots of endpoints. So if we just did this in a synchronous way within our application, this could get very, very slow. So if we get the list of who we need to notify and we start sending data and waiting for responses for each of those notifications, that's not a fun experience for a user. So instead, we move to queues and we try to break the problem down as much as possible to make a scalable solution. So something like this. On the website, all we do when we've saved the comment, we send that comment and a big list of webhooks to the queue. So we just put that data into a message and put it on the queue. This first queue is consumed by a worker whose sole purpose, the only thing it has to do, is to look at the list of webhooks and create a message on a different queue for every single individual webhook that we need to send. So if there's 1,000 webhooks registered and we get a list of 1,000 webhooks in the first message, we're going to create 1,000 messages, each requiring one webhook. This is so that our second consumer, which is actually going to send the hook, only has to do one thing. Does one thing, does it really, really well. That's all we're aiming for. Keep things really simple. And by separating out the webhooks instead of looping over them, if something goes wrong partway through, it doesn't affect the ones that would come afterwards. Each of these is independent, and we can distribute that workload across whichever servers we have available. So it's a very nice example of a scalable and distributed system. To set up RabbitMQ to achieve this kind of flow that I've drawn here, we would use something like this. So I've got 3 queues here just to show off a few of the features of RabbitMQ. First of all, I've got an exchange, and then I've got the first queue at the top there is called Events V1. I really like to have version information here in both the binding key and in the queue name, because when you come to change the message format or any kind of breaking change, you can create a queue called Events V2, bind it with a different binding key, update your application to send messages with a new routing key, and leave the old queue in place. So it's very difficult to launch a new application that writes to a queue and have the queue empty and change the consumers all in the same instant. It's basically an impossible problem. So by rolling out a new queue and then tomorrow taking down the old one once it's empty, that's a really nice way of doing a rolling release. And that's why I use the version numbers here. I think they look a little bit untidy for this, formal talk example, but I left them in because as a developer, this is genuinely how I solve that problem. And I wanted to put it here as a little reminder in case you're copying my ideas. Hopefully they'll help you. That was a huge tangent about versions. Okay, so I have this events queue here at the top. And the first thing that will happen is when a user saves a comment, we'll get a message coming on this events queue with the details of the comment and also a list of the webhooks that we need to send it to. And that events, the thing that consumes this queue, will then put a bunch of individual messages onto the notifications queue, one message for each webhook notification that we need to send. There's a third queue in this example. If you look at the bottom of the diagram, I have a queue called logs. Now, logs has a binding key of hooks.hash. I would call that a hash. I think the Americans would call it a pound. That character, however you want to refer to it, is a wildcard which can include multiple segments. This dot notation in the binding and routing keys is just a convention, but it's a really common one. And the hash means any number of segments. So the logs queue is getting another copy of every message that goes to either of the other queues. So this is brilliant for having even just a simple audit trail of things that are going through, sending it through to the monitoring to see which messages are arriving. Those sorts of things is one of the reasons why you might duplicate messages onto another queue. And breathe. Okay, we've got messages on queues, which is lovely, but it's really only half the story. So I also want to take some time while we're talking about RabbitMQ, talk a bit about workers. And this is true for all kinds of workers, whether it's Beanstalk or Gearman or whatever. They all share a bunch of characteristics that are a bit different to the web applications that I and probably you are more accustomed to building. The most important thing that you need to know about workers is they are disposable. We normally just exit if something goes wrong. And we have a bunch of workers running. It's not one script. It's usually like 12 of them, 30 of them, or however much work you need to process. And we'll have some sort of tool keeping an eye on the workers. And if one exits, we'll start up a fresh one to make sure that we've got the right amount of resource available. So this might be something like systemd, or I've used supervisord as well in the past to keep a certain number of processes running. If it's exiting really, really often on startup, eventually the tool will stop trying to restart, and you should definitely keep an eye on that as well. Beware of long-running process hazards. This is tricky. So my original tech stack, when I the first 10 years of being an engineer, was PHP. Now in PHP, if you're not familiar with it, the way that works is when a new request comes in, we get a whole new program thread. PHP starts fresh, runs from the beginning through to the end, returns the response, and then the script ends. The process actually exits and everything gets garbage collected. And the upshot of that is that in PHP, it is common to not deallocate resources. We don't close handles on things. We don't reinitialize really cleanly. It's laziness, and it doesn't matter when you're doing web requests stuff, but it does matter for long-running processes. So things that you should look out for, if you open a file handle or a database connection or a network connection or anything like that, you must close it. Make sure that you close it, even if things go wrong. If you be really careful about initializing variables, it's very easy to append to an array in a loop and forget to redeclare that array. And you could end up accidentally leaking data from a previous worker job through into the next one if you're not super careful about how that works. Also be aware of, just emptying, unsetting any variables that you finished with, particularly if they could become large. So if you're reading images into variables and that kind of thing, just try and throw them away at the end of the loop before you process the next job. And that will help keep your long-running processes healthy. A lot of people are rude to me about writing long-running processes in PHP. In fact, PHP is not the problem, but a lot of the common practices in that language don't lend themselves well. I've seen some very good long-running PHP processes, and you're probably not all PHP programmers, but all of the languages, as long as you know what you're looking out for, there's no reason that you shouldn't use them. Be aware that when we create workers, they're going to process a job. Sometimes we won't know if that job was successfully processed or not, or we won't receive an acknowledgement in time. And so things quite often get processed twice, and you should expect things to get processed in a random order. Sometimes processing one thing takes longer than processing another. We're normally running multiple consumers in parallel. So, if there are 4 workers running and there are 5 items on the queue, items 1 to 4 all get picked up at the same time, but they probably don't complete in order, depending how long they all take to run. So never expect things to be in order, and always expect things to be potentially processed twice. There are some workarounds for that, but that, in general, this is something that your code should be able to handle duplicates. So what we do is we write workers, and we give them skills, and they're essentially working on their own in the dark. They're not user focusing. We just give them skills and we send them out. So some of you might be familiar with this game. It's an old one. It's called Lemmings. This is how I think of workers. You give each of these little critters, they're lemmings, a skill, and then you send them out, and they will just walk and walk and walk and walk and walk. If they know how to build stairs, when they come to fall off an edge, they'll just start building stairs. If they know how to bash through a rock, like the one on the right, then when they come to a rock, they'll try to bash through it. And you just give them some skills and send them out. That's how workers work. Those lemmings, once you've sent them out, just need to be able to use their skills appropriately and hopefully get through the experience. So think of your workers as lemmings. To get the best from your workers, make sure your logging is excellent. The hard part about workers is there's lots of them, and they can be on different servers. So make sure that your logging is great, which is good advice for all applications, but also that it comes to a central place where you can see all the logs in context of one another, and also that you can very easily search it. So you should not have to log into one or many servers to see the logs of your workers. Those will need to ship into your Elk stack or something else log related, so that you can easily find things and track what's going on, even though your workloads are distributed. With monitoring, there are some key things that I really like to keep an eye on that I find helpful, and this is more about knowing what's normal for your system when it's working. So keep an eye on queue size. If somebody calls you out, PagerDuty goes off at 4 o'clock in the morning, and they say there's 1 million items in the queue, what should we do? You need to know whether that's normal or not. You should know if your queue is normally 1 million items long, or maybe it's normally 1 million items long at 4 o'clock in the morning because a bunch of batch data arrives. I don't know. But you should know that. And to know that, you have to have long-term monitoring and graphing of how large your queue is. Also, if it's like creeping up week on week, It's probably a problem. You need to increase your capacity, or put fewer things in the queue. Solve it somehow. Knowing how long each type of worker runs for is very insightful. If your workers normally run about 18 hours and they suddenly start crashing after 18 seconds repeatedly, something's gone wrong. And it might just be that there's an edge case which is tripping them up much more often, or it could be something much more fundamental. But knowing how long your workers usually run for without a restart, that's really important. It's quite common to have workers that self-destruct after a certain number of after they've processed a certain number of jobs. So they'll just run like 10,000 jobs and then restart themselves. What's nice about that is then they'll pick up whatever the current version of code is. So when you're deploying, you can just let your workers restart if they do that automatically on a regular basis, and they'll pick that up. The other thing I like to track is how long it takes to process each type of job. So for each queue, what's the normal processing time? Because if something suddenly gets a lot faster or a lot slower, a lot faster can be indicative of all kinds of problems. A lot slower is more common. And that's something that you want to be aware of and we want to look at. There's no point in having lovely modern distributed systems if they're inefficient. My final piece of advice for workers is that you should ship with as few dependencies as you can and also as few coupling points as you can. So in my example, the app that put the message data onto the queue in the first place also fetched the set of webhooks and put the whole lot on, meaning that none of my workers needed to look anything up out of a database or anything. When you're scaling work up like this, if all of your distributed workers suddenly start talking to a database, then that's going to add horrible load on your database, and you may find that your system ends up slower overall. So as few dependencies as possible. Knowing when things are going well or not, looking at when messages are processed successfully. By default, we will usually set up RabbitMQ so that when a worker is working on a job, it is required to send an acknowledgement to say that this was successfully processed. And if we don't get the acknowledgement within a certain time period, then we assume that it failed, and so we hand it out again. Make sure that that time period, which is configurable, is set to like longer, but like double the length of how long you think it should wait. Because if normally your job takes 200 milliseconds to complete, but the timeout is 30 seconds, that's an awful long time to wait for a retry. But if it's a difficult job and it normally takes like 20 seconds, 25 seconds, and the timeout is 30 seconds, you're suddenly going to duplicate this long-running piece of work on a really regular basis. So try and set those configurations to be appropriate. Also, if things go wrong, you can say, I can't process this message. And you need to write code that's quite defensive about that. So you just say, reject the message. I cannot process this message. And it might be, I cannot process this message now, in which case, like maybe the worker is in a broken state. So you can reject the message and request that it be re-queued. So then it will be put back on the front of the queue. So it goes straight back onto the front of the queue and gets immediately picked up again. You need to look out for what we call poison messages, which can't be processed, and try and avoid trying them over and over again. We've got the dead letter queues that I mentioned earlier. Things can end up there for 3 reasons. One, when we reject without re-queuing. Another one, messages can have a maximum time to live. If there's no point delivering this message late, if it's only valid for 60 seconds or 5 minutes, you can set that in the message when you put it on the queue. And if it's there too long, it'll just self-destruct. This is brilliant if you have a glitch in your processing and the queue starts filling up, because the messages will tidy themselves up at the appropriate time. The other reason is if the queue length gets too long, which I already mentioned. None of these queuing tools have built-in retry logic. You are going to build this yourself. Luckily, it's pretty straightforward. but the messages are immutable. So you need to create a new message, copy everything from the old message to the new message, and then add some extra information. I normally do something like just have it retry a maximum of 3 times or 5 times or something. If we had 5 goes and we haven't been able to process it, we just need to stop. It can go into the dead letter queue. We can have a look at it later. Or the other thing that can happen is we can't process the message, and it turns out it's because some third-party system is down. And then if necessary, you can just write a consumer for your dead letter queue that puts everything back on the original queue. We have another go at processing it. Now, one of the nice things about implementing retries like this with a new message is if you have a problem, you create a new message and you put it on the back of the queue. So it can just give you a couple of seconds while the rest of the queue gets processed in front of it. And then when this message gets another turn, if it was just like a little glitch in a third-party system or something like that, or even one of your own systems, then you can, often it's just enough time to let the systems all recover. So that's my secret top tip. I mentioned the feedback mechanisms. So ideally, we don't want to keep polling to see if something's finished. Instead, we can send an update into another queue to let it know what happened. So in the example from before with the hooks, we can send status updates about whether the webhooks were effective or not by adding this extra outcomes exchange and a status queue. So we can report on the webhooks outcomes into this other queue, which could be read by the original application. And if you look at the GitHub webhooks, for example, they have this. You can look at all the hooks that were sent and what the status response was and everything. Okay, so queues with RabbitMQ. I really like queues in general. They've saved my developer life a bunch of times. And they're also a very robust way to solve a bunch of problems. And they give you a lot of resilience as well. They are an extra moving part. They're not to be taken lightly, but there's a lot of problems, particularly in modern applications where we're interacting between a lot more components. We're integrating with a lot more third-party systems. There's notifications going everywhere. The queues are really, really helpful for that. I love RabbitMQ specifically. It is open source. It's very fully featured. The learning curve is, I would say, a little bit steep if you're completely new to queues, but it's been very rewarding for me to work with it. So I have certainly enjoyed it. I have some resources for you here. If you have questions, you should start typing now. I can see a few have already come in because I couldn't read and talk at the same time. On the resources list, I've got the RabbitMQ homepage. RabbitMQ have the best multi-language document tutorials I have ever seen. So if you're thinking of trying RabbitMQ now, go straight there. There are examples you can get started with. I wrote a blog post about all of the when to acknowledge, when to retry, what to do, dead letter exchanges. So that's there. It's on the work blog on Medium. I also have my own blog where I write a lot about tech. And here's a repeat of that link to the guest book code in case you're interested. Also, here are my contact details. Let me have a quick look at the questions that you've asked me. Okay, so I've got Ricardo asking me, is there a way to make a queue with unique messages? I'm going to go with no. There isn't really any way of constraining uniqueness within a queue. And I think I already mentioned that they very often, your messages will get processed more than once anyway. So I'm going to go with no. You would need to do some sort of database level weirdness. Some of these are not questions. Okay. How to work out how long you can run a worker before it's worth restarting. Sometimes you'll end up restarting workers really often because they fall over by themselves. I like to restart on about a 24, 36-hour basis, so have a look at your traffic levels, just because then I know that it's running the latest code and it's all right, and it was able to start, it hasn't run away, hasn't been frozen for days. So I think that's healthy, but I don't really have any sort of rules of thumb for that. Can you suggest any service bus framework built on top of RabbitMQ? Not off the top of my head. So I suggest that a search engine could probably help you with that one. I tend to use Rabbit fairly directly from my applications. I am a little bit hesitant to add a lot of levels of indirection. Is there a way of doing ordered message processing without having to do it yourself? Not really. You would end up needing only being able to use one worker, because it would need to make sure it had processed all the previous messages before it could process the next one. So then there's no point in having a queue. You might as well just have one script that does it and takes it from a database table or something. If it needs to be in order, then the queues are a bit of a mismatch, because they're intended to get large independent groups of work done at once. Is there a mechanism for message grouping, like the SQL Server service broker conversation groups? Oh, I'm not familiar with the SQL service broker. Message grouping, if the individual messages are not independent, then you need to create one message that has all of those messages inside it, and write a worker that's going to work through them all and in order if necessary. There isn't really a way of grouping things together. There are some neat things like priorities and stuff, but that probably doesn't cover it. Any real world advice for RabbitMQ and microservices? This question from Francesco. RabbitMQ and microservices work together really, really well. And the guestbook application that I've tried to give here is like a very small example of how I would genuinely implement that. I've used RabbitMQ quite a lot for things like communicating between microservices that prepare graphs for a report and then assemble the report and so on. I can't think of any that the code bases are open, but it's a very, very good pattern. And I think queues rather than HTTP calls between microservices, unless you're doing stuff that actually really needs to be real time, is a really good idea. And I think we'll see more of it. Can I do a quick comparison with Kafka? When to use RabbitMQ, when to use Kafka? That's a really big question. Let me try. So this is from Stefan. Stefan, so the examples that I showed today are a nice example of when I use RabbitMQ. So I've got a lot of independent pieces of data where there's actual work to do. So they need to be processed and acknowledged. So I made the comparison right at the start about Gearman being more of a job queue. So RabbitMQ I use more like that, whereas Kafka tends to be, it's more of a true message queue. So if you need to have multiple consumers potentially consuming messages at different times, but also with Kafka, you can go back and reprocess the queue again at some later point, which you can't do with RabbitMQ or the other solutions that I mentioned, then that is a good indicator that you need to use Kafka. Awesome. So a little bit then, I just want to share some Codemotion excitement with you before we wrap up for the day. I'm coming to Milan. Hopefully some of you are going as well, and that's how you heard about this. It looks like a really good event. Coming to Milan for Codemotion, that's in November. And I will be giving my talk. It's called Becoming Polyglot, because now I write a bunch of different languages, but when I'm learning a new technology, I'm not a beginner in technology, but I'm a beginner in that technology. And I think learning new tech as an expert and getting beyond once we've become expert in one thing is really hard. So my talk is Becoming Polyglot, and I'm speaking, and that will be at Codemotion Milan on November the 10th. So yeah, I hope some of you are coming down to the event, and whether you are or not, I hope this was helpful. Feel free to hang around, ask some more questions, tweet at me, let me know how your adventures in queues go, and hopefully I'll meet some of you at the event. That's the end of the formal part of this presentation for now. Thanks a lot for joining me.